almost there. Unit 12 practice test. Let's go. Let's go. Thanks, Callie. Hey, Callie, are you watching this video? Thank you. Because Callie got our class a class pet. Look at that. Can you see it? It's hard to see because it's hiding. What the? Here we go. Can you see it now? It's a beta fish. Woo! Yeah, we got a class pet. It's a beta fish swimming around and around. Way-o. All right. So thanks for being here. Cool. So here we go. 12.R. Graph each piecewise function and evaluate each function at the specified value. So first you got to ask yourself, where are my boundaries? Right? Where are my boundaries? So for our boundaries, we look at our boundaries. These are the boundaries. Cool. So for our boundaries, we're looking where x is less than or equal to -2, -2 to 1, and greater than 1. So basically, -2 and 1 are our boundaries. So we're going to draw a divider line. Not an asymptote, but a divider, just like a divider line. Yeah, divider line. So we're going to divide it at -2, and at 1, we're going to split our three equations kind of in pieces there. Erase, 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 erase. Okay, so it says all numbers. X just means what? X means all numbers. So all numbers less than or equal to -2. So that's going to be a closed hole, right? Because it's less than or equal to. Less than or equal to means a closed hole. Greater than, not equal to, means an open hole. Cool. Okay, so we have an equation of a line. Y equals, right? Y equals what? Y equals mx plus b. So our b is our y-intercept at 0, 4. That's what that means. Remember? To graph the line, we're at 0, 4. Cool. And then what's our slope? That's going to be our slope. So our slope is going to be -1/2. So that means down 1 over 2. But we're going to be going back into the left. So our slope of -1/2. So that's actually going to be, the negative is going to go with the 2. So that means it's going to be like that. And so that means we're going to go up 1. But now we're going to go back 2. Let's do it. So from our y-intercept, we go up 1, back 2, right? Back 2. And then up 1, back 2, up 1, back 2. And there's our line. However, our line is violated the boundaries. You violated the boundaries. Why did you do that? Pause me. Try it on your own. So all numbers less than or equal to -2 means that -2 or that direction. And so that means I have to erase the between -2 to 1. Erase, erase, erase. Erase, that's a 1. Yeah, so we're going to erase that. Okay, so now we got it, and it's a closed hole. And it's a line. It's a negative slope, y-intercept of 4. Check. That one's done. Ooh, so next, between -2, open hole, and greater than or equal to 1, closed hole, we have a parabola. It's shifted up 1. So we go ahead and shift up our parabola 1. We go over 1, up 1, because 1 squared is 1. 1 squared is 1. And then from, we go left 2. Do you remember? Here we go. Parabola. Start at 0, 0, or we're shifted up 1. And now we're going to go over 1, up 1, back to the center, over 2. 2 squared is 1, 2, 3, 4. So that means we're going to go up 4. 1, 2, 3, 4. Look, they connect. How pretty. How pretty, they connect. So that means we're going to go like that. Beautiful. And then to the right. However, one of them is an open hole and one of them is a closed hole. And so our open hole is being filled in by our closed hole. That doesn't happen very often, does it? Interesting. Interesting. Okay, last but not least is just, that was y equals x squared, which is a parabola, shifted up 1. And then we just have y equals 3. And so y equals 3 is right here, and it's just a straight line. And that's y equals 3. Well, what are the boundaries? Oh, the boundaries have to be all numbers greater than 1. So 1.1 works, 1.5 works, 2, 3, 4, all the way to the right. So we're going to have to erase. It is open hole, it is open. So we're going to start, not at 1, but open hole at 1. So here's 0, here's 1. So here's our 3 there. So that's basically the coordinates. 1 over 1, up 3, because that's our line there. And then we have to erase, because we don't start until we get to 1. Cool, and it's an open hole. And it's an open hole. There we go. Cool. And then to the right forever, because that's the y equals 3 line. It's just a line. Cool, there it is. So what do we have at f of -2? So that actually means x equals -2, right? So what we do is we go to -2. So -2 is right here. There's -2. However, we want to be on the function. So where are we? Are we on the function yet? No. Are we there? Are we there yet, Dad? Are we there yet, Dad? Are we there yet? I gotta go to the bathroom. There it is. So that's going to be 5. So over 2, up, back 2, up 5. 5 is our answer. You can also use the boundaries. So -2 is less than or equal to -2. So we would use the graph of a line. And we would go -1/2, x is -2, and then +4. And we write that over 1. -2 times -1 is a +2 over 2. 2 times 1 is 2. So that gets multiplied there. This gets multiplied there. And then don't forget your +4. And so that's 1 + 4 is 5. We got it. What about 1? So at x equals 1, we're way up here on the graph. And not at the hole, not at 3, no. But definitely 2 is where we're at there, 1, 2. So our input is 1, our output is 2, right? This is our input, our x value. This is our y value, this is the output. Input, outputs. Okay, what about F11? Well, this is 9, 10, 11. We're still at 3. Still at 3 on that line, y equals 3. Cool. So try it on your own. Ooh, I'm going to show you how to check your answers. How do we check your answers, Mr. Hmwk? I finally figured it out. So we do division and we do inequality symbols for the boundaries. Ready? So we're going to go -1/2 is our line. We got an x in there, right? You should probably take note of this. Take note of this, how to check your answers on the homework, maybe the test, practice test. So we're going to go +4. Okay, we got to put all of that in parentheses now. For this to work, you have to put a second insert of parentheses, put all your whole equation, your y equals mx plus b, divided by the boundary. And our boundary is x less than or equal to -2. Our boundary is x less than or equal to -2. So here it is. It's going to blow your mind. So now we're going to go parentheses, x. And then we go second test. And then we go less than or equal to -2. Boom, close parenthesis. Next equation. So next equation, put in parentheses, is what? X squared. So x squared plus 1, beautiful. And then divided by the boundaries. And so what's our boundary? Our boundary is -2. Hope this works. This might be tricky. So -2 is second test. It'll work, Google. So less than x. And then second test, less than or equal to. So then we have less than or equal to 1. And so there's our boundary for -2, 1. Last but not least, we have our y equals 3 line, which needs to be in parentheses, divided by the boundary, x is greater than 1. So x is second test greater than 1. Wayo! Let's drop it! Boom! Shakalaka! Look at that. The only thing that messed up, I think, is our parabola. But the lines are right. So if we look at our parabola, maybe we have to do a different statement, because it has 2 boundaries going on, I guess? I don't know. So let's see if we can, I don't know if we can fix that or not. Let's see. So -2, less than or equal to x, less than or equal to 1. Second test had some weird features. Let me see. Maybe you had to use the word and. So less than or equal to x, and x is greater than or equal to. Yeah, maybe we need to, I don't know. Maybe we need to use one of these options with that word and in there. So go to y equals. So x has to be greater than -2. So let's give that a try, and less than or equal to 1. Let's give that a try. So x has to be greater than -2. So let's try that one, I guess. I don't know. So x has to be second insert. It has to be greater than x has to be greater than -2, and x has to be less than or equal to 1. That's just equal, but maybe we need and in there, which let's see if it works. Boom! Yeah, it works. Pretty much works. I mean, if you're pushing trace, right, it may or may not work there, I don't know. But I mean, it gives you an idea if you did the graph right, didn't it? Yeah. Let's try zooming in there, I don't know. Zoom in. Ooh, where are we going to zoom in at? Just to see if we kind of got that right there. It just helps us see if we're graphing right. That's the idea. So I'm just going to kind of zoom in there for a second. Boom. Trace. Make sure I'm on the right graph. Where's the red one? There it is. Yeah, so this might not show the whole up there, because then you have to jump to the next graph. There it is. Yeah, so it's not showing the whole. Maybe it is. Close enough. That's amazing. Thank you. That is amazing. Cool. We did it. We did it right. Okay, so the next one, good. Give it a try there. You try. You try number 2. Come on, son. You try number 2. Remember, each of these is y equals. Each of these is y equals. So go and give that a try. What the? Uh-oh. Uh-oh. Still recording? Pen not working. Oh no, smartboard is gone. Gonna have to pause it. What the? Can't even pause it. Oh no, my computer's fried. Give me 1 second. Trying to figure out what's wrong. Pause it. I can't push any buttons to pause it. This is lame. Maybe we'll turn off the calculator? Because maybe the calculator is fried now. The calculator's like, I don't know what I'm doing. So I'm going to try to end task. Because I think the calculator might be messing things up. Yep, that's what it was. Calculator just fried its brain, graphing piecewise, just like your brains. Okay, each of these is an equation on its own, and it's being pieced together, okay? So try number 2 on your own, try number 2 on your own. We have boundaries at 0, pause me, and +2, pause me. So we have a line, y plus 2. So our slope is just 1/1, that's our slope, 1/1, and then our y-intercept is 2. So here's our y-intercept, and then our slope is over 1, up 1, over 1, up 1, over 1, up 1, which we go in this direction. However, our boundaries say left or less than 0, so that's not going to work. That line's not going to work. Yeah, how are we going to do this? Oh, well, if the slope is 1/1, the slope can also be thought of as what? The slope can also be thought of as -1/-1, because negative divided by negative is a positive. So that means we're going to go down 1, and we're going to go to the left. We're going to go back 1. Let's do it. So down 1, back 1, down 1, back 1, down 1, back 1. Yeah, there's the equation of our line. Going to less numbers that are less than 0 with our boundary. Oh, it needs to be an open hole, Newbold. Open hole. Can you fix that? It needs to be an open hole. Okay, there we go. Ooh, the next one is a cube root, sticky. So cube root, maybe you're not sure how to do cube roots. I know it's shifted to the right 1 and up 3 from our center, 0, 0. So right 1, up 1, 2, 3, that's here. And I do know that the cube root goes over 1, up 1. So over 1, up 1, let's use a different color maybe to differentiate. So there's your over, so that's right 1, 3 is our new vertex there, our new center. And then we go over 1, up 1, and down 1, back 1. Ooh, down 1, back 1. Hold on, is it equal to? It is equal to 0. We get to fill in the hole. And then remember the cube root goes up and to the right and down to the left. Cool, cube roots. So next, so that was a cube root. And cube root goes like that. Superman. And now we're going to do a square root. And so if you remember how square root works, so square root goes 0, 0. And then over 1, the square root of 1 is 1. And then 1, 2, 1, 2, 3, 4. The square root of 4 is 2. So up and to the right, up and to the right. Because if you did an xy table, it would be 4y equals the square root of x. You do 0, 1, 4. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Cool. So we're going to go and do that. We're going to shift first to the left. No, to the right 1. Ooh, right 1 and up 4. Different color time. We're going to go right 1 and up 4. 1, 2, 3, 4. My square root doesn't have those boundaries. It has to be greater than or equal to 2. Oh well, let's see if we can know where the next part is. So we go over 1, up 1, and over 1, 2, 3, 4, up 2. So our graph goes up to the right, up to the right. There we go. However, I need to erase. And what part do I need to erase? So this equation, the cube root is only from this side to this side. So I actually have to erase and only start here. It is equal to, so it is a closed hole. But I do have to go to erase, 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 erase. And the erasing I have to do is that I can't be between 0 and 2, because that's only for the cube roots, am I right? It's only for the cube root that you're between 0 and 2. Right? Yeah, because this boundary states, let's write that down in case you're just listening. Okay, so boundary states that only cube roots, right, of the x minus 1 plus 3. So only the cube root is from 0 to 2. From 0 to 2. Cool. Okay, there it is. We did our crazy looking graph piecewise. So where's x equal -2? So -2 is over here, and that's just 0. That's just a y value of 0. Where's G1? Well, G1 is actually up here at 3. And then where's G2? Well, G2 is way up here at this number, which is 5. And where's G of 10? That's a tough one. So 10 is greater than or equal to 2, greater than 2. So you're going to have to plug it in there. So you're going to have to do, because we can't really see it on our graph or predict it. So 10 minus 1, right, plus 4. So the square root, we have to plug into that bottom equation. So it's going to be 10 minus 1 is 9. And the square root of 9 is 3. And 3 plus 4 is 7. We did it! Cool. Good job. Good job. Good job. Okay, so then write the piecewise function that describes the graph shown. Be sure to specify domain as well. Well, the nice part about this is the arrows are going this way, technically this way, forever. And then it goes along and it fills in the hole. And this way forever. So this particular one for the domain will be all real numbers. There's no holes, there's no skipping or anything. So the domain will be negative infinity to positive infinity, or all real numbers. All real numbers. Nice, for this one. This one too seems to be negative infinity, positive infinity, because even though at -4 there's a problem, I mean, I don't know. I guess you could put negative infinity and positive infinity for the domain. But, I mean, really, you're getting really specific, I guess. I mean, it does fill in. So you would say, negative infinity, what would you say? You'd say negative infinity to what? You'd say negative infinity to -4, brackets in union with, no, that's a hole there, to infinity. But really, I think that's just the right answer there. Yeah. Okay, beautiful. So write the function. Okay, well, this looks like an x cubed, but we have over 1, up 2, then over, no, up 1, 2, 3, over, no, up 1, 2, 3, 4 over 1, no, it's over 2. So that's kind of confusing me. It is a cube root. So here's our function, right? So this would be, not a cube root, sorry, a third power. I think it's a third power, yeah. So it should be a third power here. And so where's our center at? It's probably right about there. And so our center is at -1, 1. So that means we're going left 1 and then down 1. And so where's our boundaries? Or where's our boundaries? So our boundaries is all numbers, so basically 1 is our border there. So all numbers to the left of 1, including 1. So that's going to be x has to be less than or equal to 1. Cool. That looks right to me. I don't know. It looks right to me, hopefully. Hopefully the slope isn't evil, because I can't really see the slope. Usually you have to go like over 1, up 1. Oh, that's a half. Ugh, and that's the y value. That's the y value. So over 1, up a half. Okay, there's probably a half in there. Super lame. Probably is. Super lame. Probably. Okay, I won't make it that hard on the test, don't you worry. Okay, what's our other equation? Upside down. Over 1, down 1. Over 1, 2, 3, 4. What's the square root of 4? The square root of 4 is 2. Down 2. So that's going to be a square root. And the square root is negative, it's going down. Upside down. Can't be found. Okay, so that's an upside down square root. We were at 0, 0. What's the shifting? What's the shifting that happened there? From 0, 0, we went over 1, up 1, 2, 3, up 3. So here's your up 3, and here's your over 1. There you go, there's your square root there. Beautiful. And so the border is just going to be greater than 3, 3 or greater. So x has to be greater than or equal to 1, the x value. Remember, the borders are the x values. X values! Okay, so this one then, let's take a look at this one now. Okay, interesting. So this one has an upside down parabola. Our vertex is here. We go 1, 2, 3, 4, 5. So we go left 5. And then we go up 1, 2, 3, 4. Up 4. So we have y equals a parabola that's left 5. Remember, it's opposite what you think. And then up 4. Up 4. Now I'm not sure. Does it go over 1, down 2? It is. It's narrow. It's narrower. And back 1, down 2. Yep, so it is going to be upside down, first of all. It's going to be negative. And also the slope, right? The slope is down 2. It's over 1, down 2. So there's going to be a -2 there. And so our boundary is going to be from all numbers less than or equal to, because of the closed hole, less than or equal to that number, which is down here at -4. And then the other one is going to be x has to be greater than or equal to, no, not equal to, just greater than 4 for the other boundary. And then this just looks like a line. It's the equation of a line. It's the equation of a line. And that line has a y-intercept right here. At 0, 1 is the y-intercept. So we have our equation y equals, we have a +1 for the y-intercept. What's our slope doing? Up 1 over 1, 2. Up 1 over 1, 2. So we're going up 1 over 1, 2. And that's our slope. And that's our slope. 1/2 x is up 1 over 2. Nice. Good job, you guys. Good job. Think you're getting the hang of it? Think you're getting the hang of it? Get the hang of it! Thanks for watching. See you on the next video. Thanks for watching. Bye for now. Hey, you. Thanks for watching. Bye for now. Piecewise. That was the hardest part. Hardest part, done.